Hey everyone, sorry that I am not here today face to face, but we're still going to have class. So here's your class. We are doing section 3.1 and section 3.2. They're actually both fairly decent sections. The first one is 3.1 and it's about reading graphs in rectangular coordinate system. So I hope you guys feel pretty confident as we navigate through this. So our first objective is our ability to reading bar and line graphs. So with bar and line graphs, I think you like, oh, I've seen this before. For example, here's an example of a bar graph. A bar graph simply because the quantities are represented utilizing rectangles. So we have the first objective here. It says approximate the number of endangered species that are birds. So if I'm approximating the number of endangered species that are birds, then I am just simply going over to birds. I'm going to find birds. Birds. Go up to birds. I'm like, not quite 80, but let's say 79. And that's all you would do as far as approximating that. So someone could say 78, 79. It would be both correct. So you keep. And then here it says which category shows the fewest endangered species. So this is just asking for me to locate the shortest graph. I look, and it looks like spiders, arachnids, would be our shortest, so aka spiders. And that's reading the bar. So then next we're going to talk about define rectangular coordinates system and plotting ordered pairs. This is where we're going into our x, comma, y, and we're going to be using that throughout. So rectangular coordinate system, first off, is ordered pair, and it's two numbers associated with a point on a graph. The first number gives the horizontal location, and the second gives your vertical location. A coordinate is in an ordered pair. You have an x coordinate and a y coordinate, and because that we are using a coordinate plane, which is made up of x and y, vertical and horizontal lines. X-axis is our horizontal number line, our y-axis is our vertical number line, and origin is our point of intersection of the two axes. So putting all that together, we have our y-axis. My stylus is tripping. Our x-axis, and then that's y is horizontal and vertical. Our origin is where the two axes meet. Try my best to use this stylus. Hopefully there's our origin. I'll put an O for origin. And then our coordinates are when we travel along our x and travel along our y. In quadrant 1, our coordinates are positive x's and positive y's. In quadrant 2, our coordinates are negative x values and positive y values. In quadrant 3, our coordinates are negative x values and negative y values. And in quadrant 4, our coordinates are positive x values and negative y values. Note that the quadrants go around counterclockwise, so instead of clockwise, we go 1, 2, 3, 4. That is your rectangular coordinate system. And I forgot to click to show quadrants. So when we're graphing our ordered pair, graphing your ordered pair means that you have a particular ordered pair that you're trying to plot. And so you have an A value and a B value, and we always start from the origin. So you start from the origin. Your A value tells you whether you're going to go left or right. So A value tells you whether you're going left or right. Right if it's positive and left if it's negative. Then your B value tells you if you're going up or down. Up or down. And B is positive down. Positive is up, down is negative. So here's our coordinate plane, and if I wanted to plot the point, I always start at my origin, so there's my origin. The coordinates for the origin are 0, 0. And then if I was to plot a point, I go to the right if it's a positive. So, for example, I went 5 units to the right, and then I'll go up as 3 units up. So the coordinate of this point would be 5, 3. I can repeat that again, and notice again in quadrant 1 how I have a positive x value and a positive y value. In quadrant 2, quadrant 3, and quadrant 4, you will have either a positive and or a negative value. So in quadrant 2, if I was to plot negative 4, 2, that means I went 4 to the left and 2 up. If I'm on the y-axis, that means that I did not go left or right. I just went up. So notice here that for our x value, we put a 0 because we did not go left or right. If I stay on the x-axis, that means I only went left or right. In this case, I went to the left, and if you notice right here, my y value my y value is 0 because I did not go up or down. If you look here at 2, negative 4, that means I'm in quadrant 4 because my x value is positive and my y value is negative. But it also means that I went from the origin over 2 units to the right and then down units, 4 units down. So here, if you end up plotting a point and it's on another point, that means that you messed up because coordinate points are very unique and they correspond to exactly one point in the plane, nowhere else. So be mindful of that as you. So let's kind of go over graphing really quick. So if I have a 4, 2, that means I'm going 4 units to the right and 2 units up. So it lands in quadrant 1. If I have if I have negative 3, negative 2, that means I'm going 3 units left and 2 units down, which puts me in quadrant 3. Looking at C, I have 2, negative 3, so that puts me 2 units to the right and 3 units down, which puts me in quadrant 4. If you look at D, I have 0, 4. Because my left and right is 0, I did not go left or right, but I did go up 4 because it's a positive 4. So I'm on the y-axis. If I have 5, 0, I went right 5 because it's positive, but I did not go up or down, so I lie on the x-axis. Graphing paired data. So when you're graphing this, you are simply plotting points. So paired data are data that can be represented as ordered pairs. A lot of times it's a real world situation. A scatter diagram is the graph of the paired data. So scatter diagrams, they are not trying to make a line, they're not trying to make any other type of traditional function that you could think of. It's just plotting the information that's been given to you. So for example, when you are given data, you want to write this as an ordered pair. So for this problem, it says that the table gives a number of tornadoes that occurred in the United States for the years shown. We're going to see on the next slide. It wants us to write the paired data. So we'll establish what will be our x and what will be our y for this problem. So our year is our x, our y is our number of tornadoes. We create a scatter diagram of the paired data, and then we decide what type of trend line is happening, meaning that is the function increasing, decreasing, or is there no trend, meaning that you can't predict. So here we have our table. So I'm going to write my ordered pairs. So my ordered pairs would be 2007, 1096, 2008, 1692, 2009, 1156. If you notice, typically this would be your x value on the left hand side, and your y value is typically on the right hand side. Left is your x, right is your y. Please excuse me. So then I'm going to plot the points. So I plot the points. Notice how I'm only in quadrant 1. The reason why I'm only utilizing quadrant 1 is because we only have positive values. We're talking about time and tornadoes. You can't have a negative year and you can't have negative tornadoes. So therefore, we only are in quadrant 1. And so then it asks me, what trend in the paired data, if any, does the scatter diagram show? If I look at this, these points are scattered everywhere. They're here and here and here and here. There's no pattern that's occurring. So therefore, I would say that the number of tornadoes just varies. There's no way I could predict this year you get more tornadoes, this year you get less tornadoes, because they vary from year to year. So now we're moving on to determining whether an ordered pair is a solution, meaning does the ordered pair make the equation a true statement. So for example, for A, we have the equation 3x minus y equals 12. So what you're going to do here is you're going to label your x and y that's being given to you, and then you're going to plug them into the equation and verify if it makes a true statement. So for example, for A, I'm given x equals 0 and y equals 12. So where x is, I'm going to plug in a 0, and where y is, I'm going to plug in a 12. So I plug in those numbers. And then you're going to simplify, which just basically means you're going to do the math. So if I have 3 times 0 minus 12, I get 0 minus 12. 0 minus 12 equals negative 12. Negative 12 does not equal positive 12, so instead of a true statement, I got a false statement, which tells me that 0, 12 is not a solution. So then I go on to the next one. So for this one, for B is 1 and negative 9. So again, I'm going to identify my x and my y. I'm going to plug them in for x and y in my equation. So where x is, I'm plugging in a 1, or y is, I'm plugging in a negative 9. I like to use parentheses to just kind of protect the values that I'm plugging in. And it reminds me that I'm also multiplying because parentheses means to multiply. 3 times 1 is going to give me 3. And then I have negative. Remember, even if there is nothing out here, there is trying to draw a 1. That's the best one I can do for you today. There's a negative 1. So negative 1 times negative 9 is going to make positive 9. So I end up with 3 plus 9. I continue to simplify, and I get 12 equals 12, which is a true statement. So therefore, 1, negative 9 is a solution to this equation. So completing the ordered pair solution. What this means is that you're given only half of your ordered pair, and you need to find the other half. So in general, an ordered pair is a solution of an equation in 2 variables, meaning that you have an x and a y, or whatever the variables are being called for that problem. As long as you know one coordinate, then you can always find the other one, and we just do that by using substitution and our solving skills. So for example here, it says complete the ordered pair 3, comma, what? We don't know. Okay? So that it is a solution to the equation 2x plus 5y equals negative 4. So we know that we're going to let x equals 3 because that's what we're given. We're given the 3 in our coordinate, which is our x value. And we're going to solve for y. So where x is in our equation, we're going to plug in 3. Once I plug in 3, now we're going to use those skills that we focused on last chapter, which is getting a variable by itself. So the variable we want by itself is y. So I have 2 times 3 is 6. And now I'm left with 6 plus 5y equals negative 4. I need to get y by itself still, so my first line of defense here is this 6. To take away that 6, I'm going to subtract 6 from both sides. When I subtract 6 from both sides, I'm left with 5y equals negative 10. Y is still not by itself, so in order to get y by itself, since this is multiplication, the inverse of multiplication is division, so I'm going to divide both sides by 5. And when I divide both sides by 5, I get y equals negative 2. So my ordered pair is 3, negative 2. 6. On 6, this time I'm looking for my x because it's blank. Like, oh, where'd you go? It's like playing Waldo. Okay, and I'm given the y values right here of negative 7. So in my equation, where y is, I'm plugging in negative 7. So I have 3x minus y equals negative 5. I'm going to plug in negative 7. Remember right here, there's that invisible 1 for us. So it's negative 1 times negative 7, which is going to give us 3x plus 7. We simplify it. And now we're going to try to get x by itself. So our goal, again, is to get that variable that's remaining all by itself. Our first line of defense is 7. So in order to remove the 7, it's a positive 7. So we're going to subtract 7. When we subtract 7 from both sides, we're left with 3x equals negative 12. Remember, x wants to be by itself. Right now, it's being multiplied by 3. And the opposite of multiplying by 3 is to divide by 3. What do I do to one side? I do to the other, and that leaves me with negative 4. So therefore, my ordered pair is negative 4, negative 7. Now, what happens when you get a whole table? Don't worry, it just means you got to do it all 3 times to fill in your table. So notice what the table gives you and solve for what's missing. So for the first row, I'm given negative 4, and I need to solve for y. That's a weird looking question mark, but go with it. So I have negative 4. I plug it in for my x. And conveniently, y is already by itself. So then when I solve for it, whatever I get after I simplify, that's my answer. So I get negative 20. So I'm going to plug in negative 20 would be in my table. Next, it says replace with 10. Well, 10 is a little different. 10 is a y value. So I'm going to plug 10 in for my y. And I get 10 equals 5x. Remember, in order to get this by itself, I divide both sides by 5. My stylus is not being my friend. That's a 5. Go with it. And 10 divided by 5 is 2. So that gives me x is my missing. 2 is my missing x. And then last but not least is 3. I plug 3 in for x. And when I plug 3 in for x, I simplify it. 5 times 3 is 15. So my missing number here is 15. Ta-da! You filled in the table. Okay. So now it's your try, your homework. So please make sure you try 3.1 homework. If you have any questions over 3.0 homework, please do not hesitate to hit the Ask My Instructor button. I will more than gladly answer any of your questions. Start with graphing linear equations, section 3.2. So objective 1 is identifying linear equations. So we're going to talk about what is a linear equation. I'm going to give you a hint. It has something to do with this word. A linear equation is an equation that typically involves 2 variables. And your variables can be written what we call standard form. Ax plus by equals c. And a, b, and c are real numbers. And a and b both are not 0. Okay, so this is our standard form. And when the graph of a linear equation, 2 variables, it makes a straight line. Remember that word I need to focus on? So linear equations make straight lines. By straight lines, they can be increasing lines, decreasing lines, or vertical lines, or horizontal lines. Okay. Example 1, we're going to determine whether things are linear equations in 2 variables. The key thing here is, the problem with example A is that, 1A, is that square. Linear equations cannot be squared, they cannot be cubed, they cannot be square rooted. Your variables need to be single variables, meaning your x and y are just x and y. B, even though B does not have a second variable, it is still a linear equation. That's because technically your second variable could have been there as 0 times x. And we just simplified it so that we wouldn't look like crazy people with the 0 times x right there. And C, even though C has fractions and decimals, it is still a linear equation. And it's just written in our standard form. Objective 2, we're going to talk about graphing linear equations by plotting ordered pair solutions. So for example, if we have this function, this equation, 2x minus y equals negative 4, we can actually create the line that this represents. So all we have to do is follow these 3 steps. Find 3 ordered pair solutions by choosing a value for one of the variables. x or y, then solving for the other variable, okay? In the way our equation is written right now, it's 2x minus y. It doesn't matter if you choose x or y because you have to do the same amount of work to solve for both. Now, if the equation was already solved for y, such as if it said y equals 2x minus 4, we would want to choose x values because our y would already be by itself, and we would easily get our y's. Step 2 is plot the solution points. Step 3 is draw the line connecting the 3 points. So we graph the linear equation, 2x minus y equals negative 4. I always say choose small numbers. Start with small numbers. No reason for you to, if your favorite number is 55, please don't use 55. One, you may not be able to plot the point on your homework. And two, why give yourself that large of a number to work with? So we have x equals 1. So I'm going to, wherever x is, I'm going to plug in 1. I'm going to simplify. And when I simplify, I get 2 minus y equals negative 4. My goal is to get y by itself. So my first thing I'm going to need to do is subtract the 2y, then subtract the 2 from y. What I do to one side, I do to the other. And when I clean that up, I get negative y equals negative 6. Okay, y is still not by itself. It still has this invisible 1 tagging along, right? So it's multiplying. So the opposite of multiplication is division. What I do to one side, I'm going to do to the other. And so y equals positive 6. Notice here that it says multiply. You can multiply or divide by negative 1. It's going to create the same solution in the end. I continually use divide because it keeps you in repetition of most of the time your last step being to divide. So therefore our first ordered pair is 1, 6. So there's 1. Then my next point, I decided to get a little more adventurous and let y equals 4. So if I let y equals 4, where y is, I'm going to plug in a 4. So I have 2x minus 4. So my job here is to get x by itself. So if I want to get x by itself, I'm going to add 4 to both sides. Going to add 4 to both sides. What I do to one side, I do to the, my stylus is not being my friend. We're going to add 4 to both sides. So when I add 4 to both sides, I'm left with 2x equals negative 4 plus 4, which comes down to 2x equals 0. I still need to get x by itself, so I'm going to divide by 2. What I do to one side, I do to the other. And I'm left with x equals 0. So my second point I can plot is 0, 4. I just need 1. So I'm going to let x equals 4 this time. Could I have chosen 0? I could have. Could I have chosen a negative 1? I could have. But I wanted to be challenging and choose non-1 and 0 numbers. So x equals 4, so I'm going to plug that in. I'm going to simplify, and I get negative 6 minus y equals negative 4. My goal is to get y by itself, so I'm going to add 6 to both sides, and I get negative y equals 2. Last thing, that invisible 1 comes into play, and so in order to move the invisible 1 or get rid of an invisible 1, I'm going to either multiply or divide both sides by negative 1, and that leaves me with y equals negative 2. So now I have 3 solutions, and my 3 solutions are 1, 6, 0, 4, and negative 3, negative 2. Once I have my 3 solutions, I can easily plot those points and then connect them. And there's my linear equation in line form. So we're going to try this again. So notice here I have negative 2x plus 4y equals 8. I'm going to start off with 0 because it's 0. Let's find 0 and let x equal 0. Well, the beauty of this is when you let a variable equal 0, it goes away because anything times 0 is 0 and anything plus 0 is itself. So I'm just left with 4y equals 8. So I'm going to divide both sides by 4 and I get y equals 2. So my first ordered pair is 0, 2. And so since I let x equal 0, now I'm going to let y equal 0. So that the same thing can happen. So I plug in 0 for y. My 4 becomes a 0. And anything plus 0 is itself. So I'm going to divide both sides by -2. And I get x equals -4. So my ordered pair is -4, 0. So those are my 2 points. And to be honest, on your homework, you only need 2 points to graph. So if you choose to use 0 as your 2 points, one for x and once for y, you'll get your 2 points that you need to graph. So I'm going to choose a third point. I'm going to choose 1. Remember I told you try to stick to the 0s and 1s. I plug in 1 for y. It doesn't matter if I plug in 1 for x. Just y was positive, so why not? Plug it in, simplify, and I get -2x plus 4. And then I'm going to subtract 4 from both sides, and I get -2x equals 4. And then I divide -2 from both sides. So I get x equals -2. So my third and final point is -2, 1. So now I'm going to plot 0, 2, right there, -4, 0, right there, and -2, positive 1. All 3 points are lined up. I'm going to draw my line. Now, I know you guys are like, fractions. Okay, here's a fraction. The trick with the fraction is that so that you don't have to worry so much about the fraction, you want to choose multiples of 4. And what this allows you to do is divide that multiple by 4, and so you end up being just left with 3 times whatever that value is once you divide it. If my denominator was 5, I would do multiples of 5. If my denominator was 10, I would do multiples of 10. So whatever is in your denominator is what you would multiply by. So the first multiple of 4 that I'm going to choose is 4. And so when I plug in 4, what ends up happening is I end up, if you think of it in 2 ways, you can think of it as 3 times 4, and that's going to give me 12. And then 12 divided by 4 is 3. Or you can think of it as 4 divided by 4, and that's 1, and 3 times 1 is 3. Either way, once you simplify, you're left with 3 plus 3, which is 6, so therefore your coordinate is y equals 6. So therefore your solution is 4, 6, is what you get. So another multiple of 4 would be 0, because 0 is multiple of everybody. And again, if I can use 0, I'm going to use 0 because 0 is the magical number that makes things disappear when added. So we have 3/4 times 0, which is going to give me 0, and 0 plus 3 is 3, so therefore y equals 3, and my second solution is 0, 3. My third solution, I'm going to -4. I've already used +4, so I'm going to use -4. -4 I'm going to treat the same as I did +4, so this time I have 3 times -4, which gives me -12, and -12 divided by 4 is -3. So -3 plus 3 is y equals 0, so my final solution is -4, 0. Now I have 3 coordinates. I'm going to plot my 3 coordinates, so 4, 6, 0, 3, and -4, 0, and then connect them with a line. Ta-da! Alright, so when graphing these, it's important to remember that it's easier to find ordered pair depending on what it's already solved for. So for our last example we just saw, it was already solved for y. So therefore it was easier to choose x values to plug in because y was already by itself. If it's already solved for x, it may be easier to use only the y values to plug in because your x is already solved and you'll get the solution in the end. So last two examples, we're going to talk about single variable linear equations. Here we have y equals 3. And so what y equals 3 means is that it was 0 times x. And 0 times anything makes it 0, and 0 plus anything is equal to itself. So therefore, 0x isn't represented. So what this tells us is no matter what value we replace with x, no matter what, y is going to always be 3. So for example, if x is 0, y is 3. If x is 1, y is 3. If x is 5, y is 3. If x is 510, y is 3. So no matter what, it's going to be 3 as your y value. And this is a horizontal line. So when y equals 3, so when y equals a number, it's going to make a horizontal line. Okay, it's going to make a horizontal line when y equals a number through the y-axis at that number. Now, x on the other hand, let's say I had x equals, this was x equals negative 5. I'm going to cross that out. X equals negative 5. And when we have x equals negative 5, that means, I don't know why it's 3. No matter what I plug in for y, x is going to still be negative 5. Negative 5. Negative 5. And so here's an example of what happens here. So if I have x is negative 5, 2, x will be negative 5, 0, negative 5, negative 2. No matter what, the x is going to be negative 5. So when it's x equals a number, it makes a vertical line. Think about the L, but there's also an L in horizontal, so it doesn't help us. But x equals a vertical line. And that is all that we have for tonight.